Okay, everybody, it looks like it's 1 o'clock, so I'm going to go ahead and get started. Once again, this is Aaron Magnan. I'm a technical marketing manager over here at Autodesk, and today what we're going to be talking about is Advanced FEA in Fusion 360. Before I get too far into it, I should probably wish everyone happy holidays and New Year. I might have forgot that otherwise, so I just wanted to make sure to get that out of the way. Um, If you've attended other webinars, there was actually one before this that on the same subject, just more of an introductory FEA course. It was by Bryce, a coworker of mine, very talented. I'm going to be continuing on with that consideration, kind of get more into more details on this side of Fusion. So real quick about me, my background is mechanical engineering. I went to the University of Nevada, Reno. I'm all over LinkedIn. I'm on Twitter. Hopefully some of you guys saw tweets from me promoting this. In the past, I was actually a simulation-specific applications engineer, and so this is something that's near and dear to me, so I definitely like to show it. I like to talk about it. I mean, who doesn't love looking at some simulation results? Who doesn't love learning more about their products? Just to quickly recap the presentation that Bryce did last time, he talked about, considerations for when these types of studies are applicable. So if you're doing like a linear static study, for instance, you're only going to want to use ductile materials in that case, something with a stress strain curve that looks like this. This is, what a typical steel will look like if you look at their stress to strain. And more specifically, you want to use it only in the region to the left of this yield strength. After that point, you start to get some nonlinear material behaviors. So just wanted to stress that real quick. He did talk about workflows, what you do to set it up, what you're doing to discretize it or mesh it, what's happening when you're solving it, and then a little bit of post-processing. He also talked about adaptive meshing, and this is something that I'm going to touch on again in this course. I mean, it is a very important side of finite element analysis just to make sure that your results are quality, that they've converged, and that what you're looking at is what you'd expect to see in the field. So just to recap, kind of what I would consider important for a new user to Fusion 360 simulation is to just get into it. It's pretty easy to use. When you get into whatever study type that you're going to be working on, you're going to start at the top and work your way down. So and I'm going to get into what each one of these different considerations are. I'm going to get into some other things, and I think that's what my next slide is going to be about, what today's goal is in this presentation. There is actually a handout that I've already attached to the GoToWebinar interface. If you're able to access it, go ahead and do that. It's just the PowerPoint presentation. I'm sure that many of you would like to see these after the fact. I am recording this, so hopefully we'll be able to post this to our YouTube channel as well, and we'll talk about that at the end of this presentation. But to circle back to where I was actually going when I got to the slide, today's goal is to look at some more details as to what happens during the setup and different considerations at each step. One thing that I thought was really slick about Fusion 360 simulation is what happens when there's interferences. I want to show you how to duplicate and copy things like boundary conditions, or duplicate or clone, I should say, entire studies. We'll talk about how to add custom materials. We'll get into some of the mesh details and finer details as to what each option does, and kind of try to drive home what's happening as you're making those changes. And we'll get into troubleshooting issues. I think this is really important for everyone to understand, to be able to interpret results, to understand, if there are problems with the results, or if it's, mathematical, or if it's, any number of things that could happen when you're setting up one of these problems. And then actually, this is a nice little thing that I'm able to do because we're getting pretty close to it, but I'm going to give you a quick preview to the January update in simulation, which is pretty important, and it's my way of showing thanks for you guys attending my presentation today. So just to get back to the setup, and this isn't all going to be PowerPoint. I do have about 30 slides, so I'm kind of clicking through these pretty quick. But in the very first part of the setup, you're actually determining whether or not you want to include or exclude bodies from the analysis. So if you were to expand out that section that I'm pointing at here in the PowerPoint slide, you'd see all the different bodies or all the different components in the model that you're currently looking at. From there, you can toggle whether or not to suppress or unsuppress bodies or to hide or show bodies, and you get all those controls that control, what you're actually going to be running the analysis on. And there's some other things you can do there, but it's not a good time to talk about it just yet. We'll get into that a little bit later. But the next one, we'll do something similar to study materials. I kind of prefer actually to apply the materials from the first section because you can dig down and find each individual body, but that's just my own personal preference. As you get further down into the setup, you're getting into constraints and loads. And these are usually things that people have a pretty firm grasp of what they're doing. I mean, loads is pretty well understood usually. I mean, you understand if it's like a force acting somewhere, or if you can actually do like a prescribed displacement. You can look at pressures, you can consider moments, you can consider different types of constraints. And what we're describing there is what's happening in the real world situation. I mean, you're designing these products that are going into real world situations, and when you run the simulation, you're not necessarily looking at it in context to the entire assembly. Sometimes you're just focusing on a couple small parts of a larger assembly. And for that reason, you use these constraints and you use these loads to translate forces into the models, or to constrain the models as they're constrained or attached to other parts in your assemblies. Now, this is something that I find to be extremely helpful, and that is our contact creation methods, how we deal with interferences, and this degree of freedom plot that you're seeing on the screen right now. This is a really good check, as you finish the setup for your analyses. You can use this tool to figure out if contacts have been set up properly, but also it's considering how you're constraining your model as well. So what you typically want to see here is that it's fully green, that it's going to be fully fixed in all directions. Sometimes, depending on the study, you might want it to be partially fixed, and you can see here it's showing potentially fixed, and we'll talk about that a little bit later. But real cool, really great visual check as to whether or not your setup has been done properly. So that little stop sign down there means that I'm going to jump into Fusion at this time. That's a little cue that I've built for myself here. And we're looking now at this pipe wrench, and we want to understand what's happening with this setup, and we're going to be looking at contact creation, using the automated contact creation, and then also how to apply loads. So with this, the first thing I want to do is check for interferences, and this is something that I learned using other simulation tools, is that if there were ever times where there were interferences, that caused you major problems. And the reason for that, as I understood it, was that when you went to go mesh it, there were areas of the model that occupied the same space, so meshing it and getting that area discretized properly was basically impossible. Fusion actually has some algorithms built in to help deal with that. So what I want to do here, first of all, is just to show you that this model I'm looking at here does have a very small area of interference. So under inspect, and you don't necessarily need to know this because it's going to fix it automatically for you. But what I want to show you is, and this might be good for you to know anyway, but there's a way to check interferences. It's in the inspect drop down here. You can see I'm about to select it right now. But I'm going to just select that, and in this case, I want to check for interferences for every body in this design that I have right now. So I'm just going to use my selection tool there to select every body. And then at this point, you might want to click OK, but you actually click this little compute button here, and that's going to report back to you any interferences that you might have. And you know what? I think that it's actually opened on a different monitor, so that's unfortunate. Oh, there it is. Okay, so actually I think maybe it was just calculating there, but in any event, this is what I wanted to show you. So this is what we're going to look at. Here you can see it is reporting that there is a very small interference. And if I want to understand where that is in more detail, I can click it here. And if I zoom in, you can actually see there's this little highlight of where this thread comes in contact with the part. Now, this is pretty minor. I mean, 0.236, sorry, I'm learning how to read again. 0.238 cubic millimeters. I mean, that's pretty small in relation to the size of this model overall. So you'd think that that wouldn't cause a problem, but in other simulation tools, that does actually do that. So this, you can actually deal with the interferences with it, but I'm going to just cancel out of that, just keep the interference. I don't really care to change it at this point. You know, it's usually a good thing to clear up any interferences in your designs, because it's actually very important to not have that when you go into production. But for the simulation's sake, I mean, sometimes you're doing these simulations, and the way that these tools are best used is that you're doing these simulations very early in the design phase. I mean, before you're going to production, so you can have interferences when you're in like a first design pass. So that said, I'll get off my soapbox here, and let's go ahead and switch my workspace to my simulation workspace. So just using the drop down here, I'm going to switch to my simulation workspace, and you'll see that I do have a couple problems set up here. And you know, the one that's active right now will either have the button next to it if your cursor is there, or it'll show in that kind of lighter gray coloration, giving me that feedback. I'm going to change to my simulation study in the middle here, contact missing, and I bet you know where I'm going with this. But what I wanted to do here was to show you, you know, first of all, there are no contacts yet for this model. If I looked at a degree of freedom plot, you're going to see there's probably a lot of, you know, free parts here. What that's telling me is, well, I mean, I can tell just by looking at this. And if I went to run it, actually, Fusion would give you some indication that contacts have not been created yet. So there's always these cues and helpers to kind of help you on your way there. But I'm going to go ahead and create the contact at this point, and I'll show you how easy it is to do. All I'm going to do is I'm going to just right-click on the contacts folder here, and you can see that there's the manual contact creation. And you know, if you're getting into a very complex study, you don't want to go and create all your contacts manually. I mean, even if you want to address each one individually, a good way to do it is just to do the automatic contacts, which will go through and it'll find every single contact in this model. And basically what that's alluding to is, you know, anywhere there's faces that are touching, or even if there's a small gap or interference, it's going to actually change and create contacts at those locations. So there you go. You can see it actually created the contacts real quick, and I'm going to just check to see if there's any questions at this point. I don't see any questions, so that's good. So at this point, I want to go ahead and just show you all the different contacts it created. And if I expand out the contacts folder, you're going to see, you know, there's a list of contacts, and, you know, it goes up to 42 in this case. And, you know, I've seen it do many, many more than that. But it's pretty neat just how quickly and easily that was done. If I want to go back and review my degree of freedom plot, we might see, okay, this is what I want to see. It is fully defined at this point, so we're happy with that. So let's close out of this. And the other thing I wanted to show you is sometimes you want to go and specifically address contacts for you know, one body or the other. To do that in Fusion 360, you're going to just go to this folder I was discussing at the beginning of this presentation, and find the body that you might be looking to address the contacts for. This is a good one because it's going to have just one or two contacts for it. So I'm going to go ahead and use this one. But if I want to find any of the contacts that automatically created, to maybe change them to something else, or to delete them to just rebuild contacts on my own, I can right click on this and I can see the ability to select the related contacts. When I select this button here, it actually goes and finds the contacts, and you can usually know when something in Fusion has been selected. It has kind of this dash underline between the name. If I scroll through this list, you'll see it. The one contact was actually the very last one. I didn't actually plan that, but the very last contact in here is the one that connects this body to this body. And I can, when I select it from this list here, it actually cross highlights in the graphics area, making it very easy to understand and select. So hope that helps. I mean, contact is something that you can spend quite a lot of time on. Let's spend a little more time on it for that reason, because I know it is so important to study, and it can trip up new users. And I should probably review what you're actually doing there. Is you're telling the solver, the tool, how these bodies are going to interact. I mean, are they bonded together? Are they glued together? Or is there going to be, sliding that can occur between those faces? These are all things that you want to build into your simulation to accurately capture what's happening with this model. So here in my other study here, I have 3 different studies that I was going to use for this presentation. What I want to do here is, again, review that degree of freedom view. So let's take a look at that. In this case, you can see that I have contact missing, but it's only between this part and the rest of the components in this. So let's create a contact now to connect it to maybe an existing part. And to do that, I'm going to use my manual contact creation here. This is the manual contact creation in Fusion 360 is actually really easy. So what I'm going to do here is I'm going to just right click on my contacts, and select manual contact. When you're in this dialog, you can see the different types of contact that you have access to: bonded, the no sliding, no separation, separation and sliding. Bonded is usually the fastest to solve. I might just make note of that. I mean, if you just need like first pass analysis, bonded is going to be a pretty nice one to use just to get those results very quickly. But with this selected and defined, let's go and now select our different parts and bodies that we're trying to connect here. So I'm going to just select maybe the part that's missing the connection with the rest of the bodies in this analysis, and maybe this pin as well. So I'm selecting one, selecting the other, and then immediately it changes my interface to just show me the part of interest. So it actually cleared every other part out of this and makes it so simple to select the face that I want to connect. So considering where this pin is, I probably want to connect, the cylindrical face of whatever this part's called. I'm not sure what it's called, but I want to connect that piece to the pin. So the cylindrical face makes good sense. So I'll select that face, and then immediately it actually changes the transparency display for the existing selection, and then now I can see the pin and very easily select whatever face makes the most sense to connect here. So if I select this guy, there we go. We've connected these bodies together. I can just right click and use my mouse gestures to OK that setup, and just like that, we've created a manual contact there. That is enough to actually, get that fully defined, because everything else in this model was. But obviously, I mean, if this was a real case, I'd want to, address the other side of this, and I'd probably use like a sliding contact, to be honest. But you can use your mouse gestures once again to do this. I'll do this real quick. Once again, repeat mouse gestures. Repeat hide. Oh, that was the last command I did, darn it. All right, manual contact, 1, 2, and again, 1, 2. There we go. We're happy with that. So just like that, I mean, manual contacts are very easy to set up and very easy to use. I think the last thing that I wanted to show you in this case was some of the loading options, and I'm going to turn off that existing load that I had there, and you can see how easy it is to suppress or unsuppress existing loads. I'm going to move this up so you can see it there. That's how you can suppress or unsuppress loads. But in this case, I want to apply a new load, and the reason for this is just the way that you can apply loads in Fusion 360 is so amazingly easy and flexible. I'm going to select this face to begin with, and right now it's 0 pounds force, so I'm going to just put a value there, 50, just for giggles, and immediately we can get into using targets to minimize where we're applying the load. I mean, in all honesty, when a person is applying a force to a pipe wrench, it's probably not along that entire face equally. It's probably focused on one end of it. So I'm going to use this limit target, and that's exactly what this does. It enables you to increase the size or decrease the size of where that force is going to be applied. It also enables you to click and drag and just move where it's going to be applied as well. So I can slide it down here to this end and apply this in different areas. Maybe applying it to the area that you see there makes the most sense. That's nice to use. If I clicked OK, it's going to apply that force just in that very small area there. Another way that we could do that, and something that I like quite a lot, is to use some of these other direction types. So dig in here and you might find something that you really like. I need to apply a real value here, or else it's going to drive me crazy, because that's just how I am. We'll make this one 500 pounds. Doesn't really matter. I'm not running this. But we can use things like angles to apply this. And this one I really like because, obviously you can apply this force in different areas and at different angles and slide it left or right. And it's just really easy, really flexible, so easy to work with. You can use vectors as well. You just need to apply some information here. I mean, this is essentially what we were doing with that other case. Is just a different way of applying it. So if your information is in vector format for some odd reason, then you have this information, this ability to apply it this way. You'll see it actually converted what I was working with before there, because I applied that at some such odd angles. It's, negative 184 in the x direction, positive 450 in the y direction, and etc. You get the point. So make sure to dig around in here. I mean, there's quite a lot that you can do. You can also use reference angles as well. I think I was saying this incorrectly before, but you just need to select like a reference edge, and then you can get into applying that force in different directions. So really flexible, really easy to use. Dig around. You might find something that you like to use quite a lot. So continuing on, I wanted to talk a little bit about all the different types of results that you can get into. I mean, obviously setup's very important, but the reason why we want to have a good setup is so that we get good results. So when you're done setting this up, you actually get the ability to look at results like safety factor, stress results, and stress results don't have to always be in von Mises. There's the first principle, third, shear stresses, etc. Displacements can be in whatever direction, or the magnitude or total, if you will. Strains, similarly, you have a lot of controls, contact pressure. You have some additional information there, but just really important to know how to dig in there and get into the results. And then also, you can change the scaling. You can change, what's visible at the time. Here you can see that I was changing the scale to get rid of the high end and low end of the displacements for this. I mean, I don't know why you'd ever want to do that. I was just kind of trying to demonstrate this for this presentation's sake. But the legend itself, if you click this little button here, we'll get into the legend options. This is where you can, change the size of it, make it larger, smaller. You can use thin legends. You can change the color styles, the transition styles, etc. So quite a lot of information you get into there. So real quick, once again, I want to just jump into Fusion and show you some of these results and show you how to manipulate this data. But here's one study that I ran with this pipe wrench, and you can see the forces being applied there. And right now we're looking at stress. So if you want to move the plots, you can click whenever your mouse cursor changes to that little hand, it means it's going to move it. Just be careful not to select in here. It's going to change every tick mark on the scale that we're looking at there. If you select the arrow there on the top or bottom, you can scale this to focus in on where where the highest stresses might be. That's probably where you're most interested in seeing this information. And again, this is where you can get into the different types of results. This is where you can get into all the different details of each one of these things. And then also what unit system you're using. You can, if you run this with an imperial style, if you run this with PSI and you want to look at the results in megapascals, I mean, obviously you can do that. You can see here. And this is where you get into the legend options, etc. Okay, so and I see that there's a hand up. If you have a question, use the question dialog box in the GoToWebinar. I'll definitely come back to answer those questions at the end of the presentation. I probably won't do it during the presentation, but yeah, just fill them out, send them in, and I'll do my best to get back to you. And if I don't get back to you during the presentation, I'll always email you back. I've done that with every presentation I've done so far. Okay, I'll pat myself on the back at this point. So let's go back into the PowerPoint. And this is something that I think is very important to cover, and it's for a couple of different reasons. I mean, you want to make sure your setup is correct, and one way that you need to do that is to ensure that your material has been set up properly, and that you're actually using the true material properties that you're working with. So It's a good double check to do. If you've used the default materials, double check what the numbers are in our system. Yours might be different. Your vendor might have some different information. But to add new materials, what you're going to do is go to Manage Physical in the Materials folder. Then you click that little button down there, Add New, you fill out the details, and then you see there that little plus is that I'm pointing out as step 3 here. Hit that, it's going to open up, the mechanical parameters, properties of your materials that you're working with, things that are important to your simulation, things like elastic modulus, density, etc. And I'll try to come back and address that in a moment here to actually show you that. I mean, it's hard to understand where all those buttons are without seeing it live. One place you can go to get material information, because sometimes it's hard to find that information, are things like MatWeb. This is a very common one. A lot of people know about this website. A lot of great information on there. Another place, kind of creative one that I've seen people get information from, are military spec sheets. The U.S. military and, well, probably other militaries as well, have these spec sheets, and they give them to contractors because those are the assumptions I think they want the designers to use when they're actually building up these models. I have links built into this PowerPoint presentation. I don't know if it comes through, so you can see that as I scroll over the link here, it's everyspec.com is a place where you can go to get these. MatWeb's pretty simple. If you just search MatWeb for that, you'll get there as well. And then also vendors. I mean, I was just searching for like some information before this presentation, and I found this Wilson's had a lot of really good information for materials. So you dig down into the types of aluminums or steels that you're using, and you find one, and here you can see, the makeup, and that's not really important for our sake, but down here at the bottom, you can see things like density, modulus of elasticity, etc. I mean, if you're doing a thermal problem, there's conductivity and things like that. So at this point, since I exited out of there, let's show you where to input these new materials. And to do that, all you're going to do is jump into your simulation workspace. Where I was saying to get to those material setups is your study materials here. So if you right click on this, you'll get into Manage Physical Materials. If you click that window that I was showing you, and again, it's trying to pop up on a different screen because I usually use 2 screens. I apologize about that. But here you can see, an existing list of different materials that we have. It is somewhat limited. I mean, we have a pretty good list of aluminums that we can get into. But if you don't find yours, you're going to click this button. This is where you go to add a new material. You type in your information here. You type in comments if you have comments, and then this is the real important one. You click this button. This is where you're going to add your physical information. This is, your elastic modulus density, etc. So if you're building a material that's similar to an existing one, I would recommend that you actually get in here and you find one that's similar. So if I'm looking for like an aluminum alloy that's kind of close to what I'm working with, I mean, I can select one of these and apply that. Just double click right on it and it brings that information over. So here's my thermal information, here's some mechanical information, here's some strength information, etc., etc., etc. Lots of information there, and just make sure to add the different information that you have or that you need for that study type. Okay, well, I hope that that information helps, and that if you're going to add materials, you now understand where to go. I think the next subject matter is very important. It's understanding how to duplicate studies and boundary conditions. So this is important if you run through a whole setup, you get all your contacts, your loads, and maybe you want to try a different material, or maybe you want to just alter a load. What you can do is just clone the existing setup, make the 1 or 2 changes, and get all your information out of that study without having to put all the same work into it. So let's see how to do that. All I'm going to do is I'm going to find an existing study in here. I'm going to change the model here to work with. And if you right mouse click the top level name of the study in the browser, you'll see an option in there to clone the study. So just like that, I can get into this, and maybe I want to try a different material for this impeller. And I'm ready to run this problem. It's as easy as that. Now, sometimes you just want to reuse or copy or move individual boundary conditions. In this case, you can left click and drag whatever it is that you're trying to move, whether it be loads, contacts, constraints. If you click and drag, it's going to actually move it. So what you want to make sure to do, if you want to retain the original settings, is hold Control or copy. It's going to, instead of move, it's going to copy that existing boundary condition that you're using. And you should see your mouse cursor change to indicate that it is copying. And you should see a plus sign next to whatever it is that you're moving. Now let's talk a little bit more about mesh settings. The first two on here are important to know, and they're pretty intuitive. I mean, average element size is going to play with the element size for the different models related to the model size. Minimum element size is used with the adaptive solving, and it's recommended to be at 10 and 20%. But for the first one, the average element size, 5 to 10% is recommended. I've definitely gone below 5. Sometimes you need more resolution than what that's going to give you. This will make your problems solve slower, but you should get more accurate results. The other settings in here are the maximum turn angle, grading factor, etc. I have some images I put together to help demonstrate what these do. Maximum turn angle is going to come into play whenever you have curved surfaces. If we take a look at these images, you can see the 1 degree effect on the left versus the 15 degree on the same model. Obviously, the 1 degree is going to adjust that turn angle to make it very, very fine in curved areas, possibly too fine. I mean, 1 degree isn't really recommended. You're going to get so many elements in these curved areas that it's not very important to see that sort of resolution, depending on what your study might be. 15 degree in this case does a better job of capturing that without over refining that mesh. Grading factor, this is essentially going to drive how fast or slow your elements grow to go from a very small element to a larger element. As you approach 1, it's going to grow very slowly. So the fine elements around this cylinder are actually going to basically take on the size throughout this whole model. Whereas the higher end of this grading factor 10, it's going to adapt extremely fast. And this is not typically what you want to see. And this is actually recommended to be at like 1.5, so it's approaching, hardly changing at all. But you do typically like to see it grow gradually. You're going to get better results that way. Create curved mesh elements. This Bryce actually created these images that you're going to be seeing in these next 2 slides, but essentially what curved mesh elements does is increases the quality of the elements. With that off, that's a first order element, so it doesn't have mid-side nodes. If you turn that feature on, it's going to have mid-side nodes. And so these 2 models represented here have the same number of elements, but the one on the right has a significant number more of nodes. So that's going to help capture that geometry better. Where you do want to turn that off is if you have a very large problem. If you just want to get first pass results, you can turn it off and get those results very fast. But typically you want to have this on. Use part-based measure for assembly mesh. So if you have, a huge part and a very small part, you don't want them to necessarily have the same mesh size. You want to capture the smaller parts geometry better. This is a case where you want to turn that on. And as you can see, the left case versus the right case, that smaller part is going to have a much better mesh to capture what's happening at that location. Now, troubleshooting issues, this is very, very important, something that I wanted to devote some time on. First, let's start with frequency studies or modal frequency studies. If you ever have modes that are at 0 Hertz, and typically it's 1 to 6 modes, what that's telling me is that this model is not properly restrained. So what the 6 0 Hertz modes represent in this case are the 6 degrees of freedom. So this part has no fixtures. You can see that the constraints here have been disabled or suppressed. So this model is basically just going to slide in the different directions, and Once this is finished running, you can animate each one of these and get a pretty clear understanding of what's going on there. When I play this first one, you can see it's going to slide in the X direction, unrestrained. If we play the next mode, it's going to slide along the Y direction, and then here on the fourth mode, it's going to start to rotate about the various axes as well. As you get into the next mode, however, that is going to represent your resonant frequencies for this model. You can just ignore any case where you have 0 Hertz as the resonant frequencies. If you ever have unreasonably high stress, I would recommend that you check out the quick tips that we did on mesh adaptation and singularities. This is a case where you have a singularity. This is a very classical representation. There's a sharp reentrant corner there. And as the mesh gets smaller and smaller in that area, the stress will just continue to rise. One way to understand whether or not you've converged or diverged, which is the case when you have a singularity, you'll see these adaptive plots. This is whenever you use the adaptive solving meshing techniques, you'll get the access to these. The one on the left you'll see is definitely converging. That's what you'd like to see. The one on the right, you have some divergence there. I would actually want to continue to refine the mesh in the right-hand case here. I mean, there is a chance it might settle, but it is appearing to jump pretty widely there, so I would imagine that we do have a singularity in that case as well. The good news is that 1 to 2 elements away from where that singularity is occurring, your results should be accurate. So you can just ignore those areas. I mean, another way to deal with it is obviously to make geometry changes to get rid of sharp reentrant corners, but in some cases it's just not feasible. So it's good to understand how to interpret the results. If your results are still wrong, there's a very high probability that the issue is from the setup. Sometimes boundary conditions are overlooked, sometimes material definitions are overlooked. If you have results that are widely off from what you'd expect to see, check your setup, check your materials, check your loads, check your contexts, your constraints, your mesh. But at the end of the day, there's 2 things that I'd like to point to you is that this is a numerical technique, and no matter how fine we get that mesh, we're still going to have some amount of error. In addition to that, I think the highest value you get from using, tools like this is learning about where high stresses might be and how you can change geometry and how you can change the design in order to get a better result. I don't put a lot of emphasis on, recreating lab results, empirical results. I put a lot of value though in understanding how you can make better design decisions from what you get from using these tools. Now for a little bit of preview of what's coming in January. You've actually already seen this. They updated this, I think the day of this presentation, and that's, the beauty of these cloud tools is that updates can happen so quickly, so easily, and seamlessly. There's quite a lot of materials you see in this list. The other major thing is we've added 2 new study types to Fusion 360, thermal and thermal stress. So it's going to essentially use a similar setup where you're going to, define things like loads. In a thermal case, loads take a different shape. They're just, radiations, convections. Conduction is going to be determined by materials and contexts. And then you're going to get different results. Obviously, it's going to give you an idea of, temperature gradients. It's going to give you an idea of, heat flux. One really cool thing that we're adding to this, not just in the thermal side, it's in all different study types that you get, is this point probe. So you can actually dynamically get updates as to what temperatures are, what stresses are, whatever parameter you're showing at that point. You can also use the surface probe and just click on different points to get results at different areas of interest. The other one is the slicing planes, and this is phenomenal. I mean, if you need to understand what the thermal gradient is and the midpoint of this, you can use this tool to actually slice this model and get an understanding. And thermal stress comes into play as well. If you have a wide range of thermal gradients or varying materials with different expansion rates, using this tool you'll be able to get an understanding of how concerned you should be about the thermal stresses. Going forward, make sure to take a look at our learning website. We're making a lot of changes. We're making a lot of updates there. Always check our quick tips. I mean, they're just 1 or 2 minute videos that talk about one particular subject, and we try to respond to what people are struggling with, what we struggle with personally, and just a really great way to learn something new. Try to release those once a week or thereabouts. Check our YouTube channel. We're always adding new stuff. A lot of it is related to learning and using Fusion 360. Check the built-in tutorials. There's quite a lot. We're working on getting some great sim ones added, so you should be seeing those shortly. I think that about does it for this presentation. I want to thank everyone for your time. I apologize if you attended the live version of this where the audio started cutting out at the end there. I didn't realize until the presentation was over and I looked through all the questions, which were actually people trying to tell me that the audio was cutting out. I believe that issue was related to GoToWebinar, not my hardware, but I'm going to try a different technique. I'm going to call in next time. So anyway, thanks for your patience. Thanks for attending. Have a great week. See ya.